All right, then. Now we have this new variable, or these two lists and dictionaries that are much more powerful and that we use quite a bit. One of the things we often end up having to do with them is go through those lists and do something with each item on the list, for example. This is a loop, or called iterating through the list. You'll recall from before that we had talked a little bit about control flow of programs and talked about sequences, which happen in every program. And all three of these happen in pretty much every program. Branching, where you have an if or a then, and you kind of say under certain conditions you do things. And then iteration, or looping, where you kind of go through a certain number of statements over and over again until you reach some outcome, or until you reach some state, or you've exhausted a list, for example. That last case where we go through a list and kind of do each item in the list until we're done when we've done every item in the list, is a pretty common thing to do as a loop. Just as an aside here, all programming languages pretty much, I think, have three generalized cases of loops, which are for loops, while loops, and do until or repeat loops. And so we're going to focus mainly on the for loop because it's the one that we use the most in Python. And then we'll touch briefly on while loops as well. So we've got let's kind of run this so that we still have it. We've got the users, there it is printed. What if we wanted to iterate and do things with this? So what we're going to do is we're going to create a for loop here. And that's done simply by using the keyword for. And if this feels like it's English, it should, because it is. And the best, just type this out real quick. The best programs in Python should feel like English. So let me just read this to you, and you tell me if you think you can understand what it does. For each user in users, print each user. So then let's just run it real quick. So not shockingly, what it's done is it's taken each of these and printed it out. They're on their own lines because when you do print, in this case we did print users, and Python is kind of nice about this and lets you print lists, at least in this context it does. But normally what it does is it will print each string and then put a return after it. And so what it does is it first sets this variable, each user, as Alice, and then it does everything in the block. Remember that when we indent it, it's a way of blocking off code. So in this case, we've only done one command. We could maybe separate this out by putting in some, I don't know. We could do something like put some hyphenated spaces in between. And in this case, what it would do is it would put that in between each one, because it's going to do each of these statements because they're indented within this loop. So it's going to go through all of the sequence that's indented each time, setting it to the next thing in the list until it gets to the end of the list and doesn't have anything else to do, and it will go on to the rest of the program. In this case, we don't have any rest of the program, so it just stops there. So that's it. You know how to do a for. This could be the shortest video ever. Let's talk a little bit about some other things we could do here. We could, let's say we wanted to set up a speed dating activity. We could actually go from one loop and then do a second loop. In this case, we're going through the same list. We're just going through it with two different variables. And then we'll go ahead and print out who's dating whom. So because this is going to be kind of twice in. So in this case, we're doing this. We have one statement that we're going to do for each of these, and then we have one statement that we're going to do for each of these. So how many times will this statement be executed? Well, this statement will be executed 8 times. 1, 2, 3, 4, 5, 6, 7, 8 times, right? And then for each time in those 8 times, this statement will be will be executed another 8 times. So in total, we'll end up with 64 lines, right? Let's try it. There we go. So in the first instance, each user equals Alice, and then date equals Alice, and then it prints Alice is dating Alice. Now we go back up here and we set date to Bob, and then it does Alice is dating Bob, and then we go back up to here and set date to Charlie, and then print Alice is dating Charlie. Go keep on going through this so we get to Alice is dating Zeno. And then finally this loop is done, right? Because it's been through all of that. And so then it bounces through and it kind of finishes out. And now it goes back up to here and sets this to Bob, right? Each user is set to Bob. And now we get to do this whole statement again. And it goes through the whole thing again. Now, if Alice has been dating around, she probably doesn't need to date Alice. So we could probably put in a conditional here. If each user, I think we touched on this, but then avoided it. I'm going to use the not equals, equals sign here. So we've used equal to say is their equivalent. Here I'm going to use the exclamation point with an equal sign, which is an operator that means these two are not equal. So if each user is not equal to the date, then we're going to print it. Oops. What's the problem here? Well, this needs to be indented because it's a block. We've now gotten 4 levels of indentation. I'm going to touch on this briefly here. It doesn't really matter for us using Colab right now, and in a lot of IDEs, which are editors for programming, interactive development environments, it will do this for you. It will kind of remind you that you need to do an indentation, and it will keep them all consistent. But if you're, for some reason, coding in a regular text editor, you'll need to decide whether to use tabs to indent or spaces. If you use spaces by standard, it's 4 space. It doesn't matter actually, but the kind of style is 4 spaces. You'll need to be consistent about that. I've actually hit errors where I used tabs in some lines and spaces in others, and I could look at that until I was blue in the face and I would not see what was wrong because it looked exactly the same. But tabs and spaces are not actually the same thing, even though they get you to the same place. So that's a caveat you probably will never run into as an error, but if you do, it's really hard to remember that that's the issue, that you stupidly mixed up or someone else did some of the programming using spaces and then you use tabs, for example. Anyway, so now we've gotten rid of the issue of Alice dating Alice, because when we get Alice equals, in the first instant here, we get Alice is the first one here, then Alice is the first date here. But here we get if Alice is not equal to Alice, and that's false, so we skip this and we don't do the Alice is dating Alice or Bob is dating Bob. It skips those in this list. Cool. We could do something similar with, we're going to go all the way down here. We could do something similar with, you'll recall we had these the age items here. We'd use the ages of these people to set up our dictionary. And we're going to do something, I said that we kind of use, this variable is called the index. So for each user in users. Generally speaking, that is a single variable. In fact, almost always that's a single variable. But I wanted to give an example where it's not necessarily a single variable, where we could use, a pair of variables. And we'll do that here. So for each name, comma, their age in age.items. So we hadn't hit items before. Items, it says right there, is a built-in method, is a method of a dictionary. Or age is a dictionary. So we have a method here, which is age items. And what it says is that the age, when you say items, it makes that into a special kind of format of a tuple that you can use and pull out individually with commas. So I don't know how often you would use this particular construction. It's a little strange, but you might run into it at some point. And so what we've done here is each time each of these is going to change, and we can kind of then have a print statement that prints this out in a pretty way, where we say something like print each name is their age years old. I probably don't need to remind you, but I will. You could look real quick, and you should at this point. This should be second nature. You should see what's wrong with this, which is this is a string. This is not. This is an integer. So we need to go ahead and make that into a string by typing it using string. So we'll do that real quick. And we can run that. Bingo. Alice is 22 years old. Bob is 65 years old, etc. If we were trying to think about this, often when you're thinking about programs, you try to think about what will break it. What might break it is if Charlie wasn't quite the right age yet. And so we'd probably want to put in a conditional there, which is if their age is more than 2, then we do this. And we'll go ahead and copy this. There's other ways we could do this as well, but this works. There's always other ways to do it. Back up. Else. This is the case. Well, we should probably just do if it were 1, but that's okay. It's too late now. But because I don't know that we would have 0. Their age is 0, but that's okay. We'll do it so that it's that way. And if we run this, Alice is 22 years old, Bob is 65 years old, Charlie is 1 year old, Dutchess. So in this one case for Charlie, it's kicked it out and realized that we only need a year and not years. Like I said, if we had 0, it would say 0-year-old, which is weird. So probably we should reverse this and say if their age equals 1, then do 1-year-old. That's okay. This works fine. So that's basically iteration. I don't think there's anything beyond that for the for we need to do. We should talk briefly about the possibility of doing a while loop as well. So, and then we'll touch on something that I don't like to talk about. So we could do this. While true, let's start with, let's just teach it how to count. X, we're going to assign X the value, the X the value of 0. While X is less than or equal to 10, print X, and then we're going to increment X, add 1 to X. So X equals X plus 1, or the other way to do that, you'll recall, is plus equals 1. So this is a loop that goes through, and as long as this part is true, it does this stuff below. So let's try that. So we start with X equal to 0, and it says while X is less than 10, it is. Let's make this a little faster to go through. So while X is less than 2, which it is, we'll go ahead and print X. So X equals 0, so it prints out a 0 to the console. And then we add 1 to whatever value is in X. So we now X is equal to 1. Goes back up here. Is 1 less than or equal to 2? It is, so it prints a 1. And then it adds 1 to that. Now X is equal to 2. Goes back up to here. Is X less than or equal to 2? Yes, 2 is less than or equal to 2, so this is still true. And then it prints that. And then it goes down here, and now X is equal to 3. It pops up to here. Is 3 less than or equal to 2? No, that's false. So then it goes back down here and continues on. We don't have anything to continue on down here. We could have something that prints done, for example. But we don't have anything to continue on. The program's just over, so it's done. Cool. Let's break it. What's the problem with this one? Well, this will go on forever. This is an issue with programming something where if you run this, it'll just sit here and keep adding numbers until the end of time. It's an infinite loop, something you generally want to avoid in programming. Now, if this did happen, we could go up to runtime and we could interrupt execution and stop it from running. It's kind of like hitting the break key. When I was an undergraduate, we were programming the original Macintosh, those little tiny boxes. We were doing assembly language programming, and there was no way to have a break key. They actually had to drill. They had to drill into the back of the units and put a little button that you could push to break it, because otherwise it would just the only other thing you could do is physically unplug the computer and plug it back in. So luckily we have ways we can do breaks in here. Control C is generally a way to break. In this case, you'll see that there's an interrupt, which is a Control M, or you can do a factory reset and reset the entire runtime. This basically is the same as hitting the button on a computer. This is generally not something we'd want to do, though. There is a way to get out of this if we do, and we could have something in here that says if X is, for example, now you will see this, and what break does is it breaks whatever loop you're in and knocks you out. So what this is going to do is, rather than having it here, which is where it belongs, we have a condition here that kind of knocks you out and lets you get out of this loop. So if we run this, it gets to 50, and when it gets to 50, 49 actually, because it does it here before it prints it out again. When it gets to that, when it increments the 49 to 50 and then gets to here, it breaks it out. Now, there's nothing, this is correct Python. There's some part of me that says this is just really not elegant. Certainly not having a while loop with true in there. So generally I like to have conditions there, and I don't like to use breaks. I don't think using a break is the best way to do things, but I just want you to know that it exists. So there we are. Those are the two major ways that you do loops in Python, and you use them for lots of different things. In a minute, we're going to use them to tell a turtle where to go. All right. Thanks very much.